Okay, so welcome back. Today we're going to continue our discussion of how to write some simple C++ code to allow you to import 3D objects into your code. And this is part of a series where we're talking about developing a 3D ray tracer. And in the part 10 of that series, we were looking at using some open source software and found there were some issues with it, very difficult to debug. Documentation really was not very good, so it's a fairly simple task. So we decided we would write our own code. In part one, we talked about the basic design and how we're going to set it up. In this video, we're going to talk about the actual parsing routine to parse the file, which looks like this. It's basically a text file called an OBJ, or a wavefront object file. And it's got vertices, it's got texture coordinates, normals, and faces. And in this video, we're going to look at actually parsing these into numbers. And as we said before, we're going to have vectors of floats or integers. Ultimately, we will probably need to convert those into our own custom, like vec2 or vec3 class. Right now, we're just going to use the standard vectors, and then later on, we can optimize that to match our ray tracing code. So in this video, we're going to continue looking at how to parse our object. And as we showed before, we're going to be working on this simple cube object, which is described by this very simple OBJ file. And here we are using a feature of Visual Studio that allows you, with an OBJ file, you can double click and it will give you a visual description, and you can look at it, and you can move it around, and you can edit it. Let's take a look now at the actual code to do the parsing. Again, we are at the point where we've got a vector of all of these lines that we brought in from the text file. Each line is a string, and we've got a vector of strings, and now we need to go through and parse each line, determine, is it a vertex, is it a texture coordinate, a normal, or a face? And based on which type of line it is, we're going to parse it. Here is where we left off before in our parse obj function. And it's taking in a vector of string, which is the vector of all of the lines in that file. We've got some initializing stuff. And here is a list of the 3 vectors of floats that will be kind of the output of what we parse. So we'll have a vector of floats, which is vertex position, texture coordinate, normal vector. So here is where we left off. We've got this for loop, and it goes through each string, which represents one line of the file. It goes through each object record strings, and it uses the dot size to find out how many lines are in that file. And it just goes through and does the parsing. First thing we're going to do is we're going to create each line, so object record strings I, to what's called a string stream. We talked about that in previous video. Basically, it allows us to use a method such as getLine, which is very useful here, to parse the file. So we're going to convert this string into a string stream, and we're going to call it sstream. And then we're going to do a while loop, and we're going to use this getLine method, and it's going to get from each string that we input, represented by this S stream. So we've got one line, we convert it to an S stream, and the output will be a value. And getLine is going to use what we've got here, which is a space, as a delimiter. And you can see here, we're going to go through and get the first set of characters before the space, and then grab those and determine, is it a V or a VT or a VN. So it's going to parse the line based on the space and return what it gets before the space as value. So value should be the first character or character set with a V or a VT or whatever. So now we can go through and we can parse it. If value equals V, if it's a vertex, we basically need to convert this to a vector of floats, of 3 floats. So if it's a vector for int j equals 0, j less than 3, we do a getLine based on another space delimiter to this next value. So it goes through, and for all 3 values, it parses that string stream, gives you the value as a string. So it will give you the first number as a string. And then we can convert that to a float by taking that value that it returns, doing a string to float, and calling that val float. And then we can push that val float into our vertex position vector of floats. So basically each line, it's pushing these into a vector of float. Then once we've got those three values in that vector of vertex position, then we can push that vector into our vertex positions using pushback. So now the next element of vertex positions is going to be those three values for that line, okay? So pretty straightforward, and we do basically the exact same thing for the texture coordinates. If it's VT, we're only going to have two values for the UV texture coordinates. So for j equals 0, j equals 2, we do the exact same thing. And then we convert that value to a val float and push that into the texture coordinate vector of float. And then we push that into the texture coordinates. And when we get done, each one of these, like texture coordinates and vertex positions, will hold vectors of all the texture coordinates and vertex positions and so on. So we do the exact same thing with the normal, the vertex normal, 0 to 3. We go through and do these, and we get line, return the value, convert it to normal vector, and push that into normal vectors. So these three basically do the exact same thing. The only difference is how many values. And then we get into the face. If it's a face, we're going to have these groups of integers, which represent indices. So this is going to be a bit of work to do the parsing, but it's really not too bad. So if it's a face, and I've got some comments in here, we do the same thing. We use getLine. That is basically going to use the new line character to get the entire line and return it as value. And then we will convert value into a string stream called face stream. And then we're going to go through and parse the line based on the space delimiter between each group of data. So it's going to be based on this space delimiter and this one, and it's basically going to jump through these based on that space delimiter and parse it. So the value is going to be, in the first case, it's going to be this 1, 1, 1, and we're going to use another method that we have here called parse face indices. And it's going to take each group of these three numbers separated by a slash and parse them. And it will return a vector of ints. So and we'll look at that in a bit, but basically that parse face indices gives us a vector of, in this case, 1, 1, and 1, and then 2, 2, and 1. So then I'm going to push those into the indices. So ultimately indices will have all of those indices pushed into it, and then we can go through and parse those by face. So we'll look at parse face indices in a bit. We're going to increment the verts per face so we can keep track of how many verts per face. And then we're going to push those for each line. We're going to push that into a verts per face vector, and that'll keep track for each face how many vertices per face. And then we're going to increment the number of faces. So that's it. Now we've got them parsed. What we need to do now is we need to take all the indices elements and create individual face components. So here what we're going to do is we're basically going to take those three numbers and push them back into the appropriate vector. So the first one's going to be in our vertex indices. The second one of each group is going to be texture indices. And the third one is going to be normal indices. And the 0th element is going to be the first number, which is for vertex indices. The first one is going to be the texture indices. And the second one is going to be the normal indices. So here we're just we're separating out the first, second, and third and putting them in the appropriate texture indices. And though that is from a face class, all right, we talked about before. So we've instantiated new face each time, and those are members of the face class. So now we are making faces for each line and pushing the member variables with these individual indices. And then we're doing some incrementing of the j and I to keep track of the number of verts defined in each line. And then for each face, we're doing a faces pushback to put that into the vector of faces. So ultimately we have the faces that have the individual vertex indices, texture indices, and normal indices. So that's pretty much it for the parsing. Let's go into this method where we do parse face indices to see what it does. So here we are with the parse face indices, and we give it a index group, a string. You can see down here in our parse obj, we use parse face indices and give it that string of the three numbers separated by slashes. So we're giving it the three slashes that look like 1, 2, 3. And we're defining a string called value, which is kind of intermediate value, and a vector of indices that we're going to push these three numbers into. All right. So the incoming index group is a string that looks like 1, 2, 3. We need to parse and convert to a SD vector of unsigned int with 3 elements. So again, we're going to take that group of 3 elements separated by slashes, convert it to a string stream called inStream, and then we're going to parse it using getLine, and the delimiter is the /. So it takes that inStream string stream, puts out a value. So the first one is going to be the first number, or the index, and then we're just going to push back that value converted to an integer. So we take that value, which is like a 1 or a 2 or a 3 or whatever, string to integer, push that back into indices, and then return indices. So really pretty straightforward. You're just taking those 3 numbers and returning a vector of ints representing the three integers in that string. So that's basically it. That's all we need to do for parsing. And what we can now do is we can, with this code, we can check to see if this is working. So what we're going to do is we are going to import a torus that we generated in Blender. And Blender is a really great way to generate objects that we can export and then bring into our code here to verify that everything's working as expected. So here is the torus we're going to try, and we're going to run this code and see if everything works with this more complicated torus. So let's put torus as the input, T-O-R-U-S, and we'll run it and see what we get. Okay, so it ran, and it's got 575 faces, and what we're doing is we're printing out some of the data associated with that. So there's 2,083 records, 576 vertices, 288 normals, and 576 faces. And if we look in Blender at the torus that we started out with that we exported, you look over here, it's got some statistics about this torus that we're using. And it says one object, 576 vertices, which matches up with what we just found, 1,000 edges, faces 576. So that matches what we showed in our code. It says 576 vertices, 576 faces. So 576, 576. It also says that we have normals 288. Now, is that correct? When you think about it, a normal is generally associated with a vertex or a face, right? You can have face normals or vertex normals. However, in both cases, there's 576 vertices, 576 faces. Why are there only 288 normals? Maybe there's an error in our code. Let's take a look in Blender at this and see if we can figure out why it says 288. If you look at this and scratch your head a bit, you might think, well, you know, some of these normals might be duplicates. With a cube, all the face normals are facing in a different direction. With these, maybe some of the face normals are facing in the same direction. And we can check that out in Blender. For example, we're in edit mode, we can select a face, and there is a very nice selection mode. Select similar, and you can select all these things. You can select similar normal. So let's try that. Hey, we've got another face we've got two faces selected. We've got this one and we got this one, which tells us there are two faces with identical normals. So maybe that explains why there are only 288 normals with 576 faces, because it is referencing the same normal for two different faces. So that's the case for all of these. That's why there's only half as many normals, because half of them are referencing the same normal. So that's one good thing about indices, where you can, give a number to a normal, and if it's used by multiple faces, you can just reference that one normal and not waste memory on a bunch of normals that are just repeats. So another good reason why it's really good to use Blender, if you're going to be working on ray tracing or 3D stuff, really good to use Blender as a way to verify your code and make sure everything's working right. Also, I'm listing out for each face how many vertices, and you can see I've got 576, and each one is 4 vertices. We know that's true. If you look at this, it's good. So it seems like our code is working. So now what we have so far pretty much parses the majority of this. Of course, there's no recognition of the material libraries and the use material and some other aspects of an OBJ file that define the object. Maybe if I get interest in the future, we'll cover that too. But I think we've got most of it done, and next we would probably want to look at how we could integrate the results of this, our vectors of vectors, into our ray tracing code or whatever code we're going to use for this, and see if we could implement our arbitrary objects out of Blender in our ray tracer. If you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications. Most of all, please let others know that we're here so we get some views. Otherwise, take care. Have a really good day. Thanks.